Hey everyone, and welcome to another JetBrains webinar. Today we will be hosting Steve Collins with a promising talk about .NET 5 dependency injection. I'll bring him in shortly, but first let's cover some practical details. So first of all, this webinar is being recorded, so if you want to watch later or you have to drop off for some reason, you can always find the recording later on this YouTube channel and on our blog. If you have any questions during the session, of course, this is interactive, it is live, so you can ask questions in the chats. We'll try to answer them as we go along. And at the end of the session, we'll also ask Steve for some answers if there's something that we can't help with. And with that, let's see if we can bring in Steve. Hi, Steve. Welcome.
Hey, Martin. How are you?
Good. How are you?
I'm fine, thank you.
I'm really looking forward to your session here, so I'll not waste too much time and just bring on your screen as well and give the stage to you. Looking forwards.
Brilliant. Okay, thanks. Thank you, Martin. Good afternoon, good evening, or good morning, depending on where you are watching in the world. Thank you for coming along today. My clicker's stopped working. That's better. Right. First things first, quick introduction from me before we get going. My name's Steve Collins, as you probably guessed by now. I've been programming in one form or another since the early 1980s, but professionally I've been doing this since the early 1990s, starting with VB3 right the way through to now using .NET 5. As I've got quite a common name, I go by the alias of Steve Talks Code for both my blog and my Twitter handle. As I've got a lot to pack in the next hour, if you've got questions, pop them in chat. Hopefully Martin can maybe answer bits as we go. If there's any in-depth questions, we'll save them for the end and I'll try and answer them as best I can when we get to the end of the talk. So with the introductions out the way, let's take a deep dive into dependency injection. So before we get going, as this is a deep dive into more advanced topics about dependency injection in .NET Core and .NET 5, I've had to make a few assumptions about what you already know about it. First is that most of you are familiar with using a host builder of one flavor or another to go and create the container. Whilst you can also create the container directly from the service collection without a host builder, I'm not going to focus on that too much in this talk. Next assumption is that you're familiar with using a startup class to register your services via the configure services method. And then you point the host builder to your startup class using the use startup method. So as you can see here, we're using the default host builder to set up a web application using the more specific web host builder. Next, there's various types of dependency injection supported by many IOC containers. But for now, what you need to be aware of is that out the box, the .NET Core container that comes with .NET Core and .NET 5 only supports constructor injection. Now, when I say .NET Core, throughout the rest of this talk, treat that interchangeably with .NET Core, .NET 5, .NET 6 going forward. This is what we're focusing on. I will be calling out a couple of specifics about .NET 5 and C#9 later in the talk. If you're using ASP.NET Core, you do get to take advantage of one other type of dependency injection, and that's method parameter injection. As you can see here, all you need to do is add the from services attribute to the parameters you want injected from the container into your controller actions. This means that if you have many actions on your controller that have different dependencies, you can avoid injecting all of them into the constructor. This makes your controllers and your action methods more aligned with the single responsibility principle from Solid. Usually, if you want to go beyond the basic out-the-box experience with the Microsoft container, you'll need to usually look at using other containers. But before I cover that, let's look at some of the other injection types that aren't supported out-the-box by the .NET container. Firstly, we have property injection. This is where a class is a parameterless constructor, so dependencies have to be set via properties once the instance has been created. Once all those properties have been set, you usually call a method something like initialize to then prepare the object for use. Next, we have named or key-based injection. This is where you identify the dependency you need based on some key value, typically string or enum or some constant. Lastly, while it's not an injection type as such, we have the automated service registration by convention. which is quite a mouthful to get through in an afternoon. But in short, the container scans referenced assemblies and pulls out the classes and interfaces that it wants to register based on a set of conventions or rules that you specify when you're setting it up. The good news is that I will be showing you some workarounds so that you can implement these without having to necessarily resort to using another container outside of the .NET container. But why are those other styles of injection not supported? Well, the Microsoft container is what's known as a conforming container. This is a term coined by Mark Seaman to describe a container that acts as an abstraction over other containers. The problem with this is that only the lowest common denominator of functionality is supported. So whilst the Microsoft container is a container in a standalone in its own right, because it allows other containers to hook into a common interface, it's fairly basic in what it can do. You're probably aware that there's a number of other container frameworks out there that have been around from .NET Framework and have carried forward through to .NET Core and .NET 5. In this slide, I show the ones that are listed on the Microsoft Docs website as having been adapted or extended to work with the EI service provider interface. The downside is that if you want to use functionality that is not directly supported by the Microsoft container, you end up having to manage your interactions with both containers side by side. This means you need to know how and who is resolving your dependencies for you. But before we look at the other containers, let's look at how you set up the out-the-box container. In this snippet here, we have code that you're likely to be familiar with. Here we're just registering some classes with the service collection and giving them different service lifetimes inside the dedicated startup class. Now, as we've already covered, in most applications, you'll be using a host builder that initializes the service collection with some default services. Once it's done that, it will create an instance of your startup class and then call the configure services method to add the registrations you have specified as shown here. After that, it will then call the build service provider method on the service collection to go and create the container instance based on these service registrations. Once built, the container can then be used by the application to resolve instances of services whenever they're required. Now, if you go back a bit and you're familiar with .NET Core 2, you will have been used to building the container inside your configure services method and returning it as an iService provider instance. And that was the way you were able to wire up alternative containers. As an example, here I'm using AutoFac to register an AutoFac module and return a new AutoFac container in the .NET Core 2 container. This all changed with .NET Core 3, as the host builder expects that it will take care of calling the build service provider. In fact, if you try and return a service provider from configure services in Core 3 or .NET 5, you'll get a Roslyn Analyzer warning. The reason for this is that the provider instance you create is not used by the host builder, and you've incurred the expense of creating a container just for it to be thrown away again because the host builder is going to do it again for you. What this also means is that whilst in Core 2, there was a small performance boost by implementing the iStartup interface when using the web host builder. This is no longer really true and when using the generic host model. But if you can't create the service provider in your startup class, then how do you wire up an alternative provider? To do that in Core 3 and .NET 5, there is now a use service provider factory extension method that you add to the host builder to get the alternative container to resolve the instances for you from the Microsoft abstraction. Whilst that will register the custom container, you still need to go and perform any container-specific configuration within the configure container method. You can do this using the configure container extension method on the host builder, but to be honest, it's a bit of a pain, and it's a lot easier to do that inside your startup class, as shown here, with an example for AutoFac. Whichever way you choose to do this, you need to set the parameter to receive the builder instance that is specific to the third-party container you are using, so that you can use the container's own registration methods. So again, using AutoFac as an example here, it will provide a container builder instance where you can register your modules. It's important to note, though, that as the container is built by the host builder, you can't actually access the created container until you get to the configure method. That's where you access it via the application services property. So, having covered how we get the container to be built, let's give some consideration to the lifetimes of object instances that you want the container to create for you. I'm sure that this is probably familiar territory to you if you've been used to using .NET Core for a while, but I've included it to make sure everyone is the same level of understanding before we start delving a bit deeper. Firstly, we have singletons. These are created only once and live for the duration of the container's lifetime. Next, we have transients. These are our fair weather friends that come and go as and when needed. Last but not least, we have scope lifetimes, which stand kind of between the two, but I'll cover those in more detail a little bit later. The thing to consider with these different lifetimes is that some play well with each other and others you should try and keep apart. So let's break it down a bit more. Starting with the shortest lived of the lifetimes, the transient can accept objects created with any of the 3 lifetimes. Moving up through the lifetimes, next we have scope lifetimes, which, because they're slightly longer lived than transients, shouldn't have transient lifetimes injected into them. Lastly, as the singleton is the longest lived of all, that should only have other singletons injected into it and not the other 2. Now, I'll try to choose my words carefully when describing these relationships, because there's a general misconception that it's not possible to inject incompatible lifetimes into each other. That's not strictly true. I can't speak for other containers, but the Microsoft container won't actually stop you. If you have a singleton and its constructor requires an instance of something that has been registered with a shorter lifetime, the container will happily give you that instance. The problem is, the instance you get will have its lifetime promoted up to be the same as that of the receiving instance. In other words, a transient instance will be locked into a singleton and not released until the singleton is disposed of. And that doesn't happen until the container is done and dusted. This is known as a capture dependency, where the transient or scoped instance, like the insect in amber shown here, is imprisoned in the outer shell, which in our case is the singleton. But you may want to hit pause there and say, hang on, when I've done this before, I've got an exception. That can occur. By default, it only happens when your ASP.NET Core environment variable is set to development. This is done by some hidden magic that lies in the host builder. However, you can explicitly turn this behavior on by setting the optional validate scopes parameter to true when creating the service provider. This does have a performance hit at startup though, so the general guidance is not to do it in production. Whilst I haven't got time to cover it here today, there's also a validate on build method, and that will try and help identify registration problems where you've got a dependency on some other class that you think has been registered and hasn't necessarily been so. As I say, it's fairly limited in what it can and can't identify, so I wouldn't wholly rely on that. So moving on, given that singletons live a long time and can be dangerous when mixing with other lifetimes, let's consider why we use singletons and the typical use cases. Given singletons can be accessed anywhere within an application, things get tricky if your application starts using multiple threads, typically like your web server application, for example. Therefore, singletons should ideally be stateless, so you avoid threading complications. But sometimes you may well have some kind of state that you do need to share. These might be pooled resources, in-memory queues, or some other type where you are in control of a limited resource that multiple things are dependent upon. Factory classes I'll talk about later, but typically these are created once, and then their methods are used to create shorter-lived instances of some other dependency when it's required. You may have an ambient singleton, which hides the complexity of accessing shorter-lived objects, something like the HTTP context accessor in ASP.NET Core that uses async local storage to avoid the capture dependency problem. The last of the cases shown here is immutable state, where you don't want to have to recreate a resource object over and over and over again when you know that the data will not change while the application is running. So, for example, you might have some lookup data you only want to read once from a slow repository at startup, such as a database, a file, or something on a slow network service. If you really must have state, give some thought to letting .NET do some of the heavy lifting for you. If you've got collections, consider using the concurrent collections namespace, where some of the thread safety stuff has been done for you. For read-only properties that have an underlying field, Try and make that field read-only so that if someone comes along later and tries to make that property read-write, you've put some guardrails that makes them think, well, this is read-only. Why do I really need to make this read-write? If you go ahead and those properties really do need to be read-write, you may have to resort to using a thread lock. Now, this is contentious, but bear with me. So in this slide, we can see that we're ensuring all property access is managed by a thread lock. That way we can ensure that the value is only changed by only one thread at any one time. Now, you're probably 2 steps ahead of me, but the problem with this approach is that by serializing the access to the property, you'll get a major performance hit as you are forcing everything that touches that property down a single one at a time alleyway. And you end up with threads queuing up, or even worse, potentially if you've got circular dependencies, you could end up with thread deadlocks. If that happens, you probably need to think about your design, because if you've got that kind of thing going on in a singleton, you may want to take a step back and think again. Don't have a panacea for this, not in this hour anyway. I'm just warning that this is a code smell and you probably want to address it. Lastly, consider the impact of having disposables in a singleton. Whilst this isn't a threading race condition, like the ones I've described above, the problem here is that if you expose the dispose method and a consumer calls that dispose method, everyone else has potentially lost access to the disposed resources, which can cause an object disposed exception to be raised elsewhere in the application. However, you do still need to make sure that the dispose method is there for the container to clean up after itself once it's done with the disposable resource. To get around this, you may want to consider abstracting the class with an interface that exposes all the members except the dispose method. That way, given that the service type is an interface and not the concrete class, when the instance is served up to from the container, you've put some guardrails in place that can make it difficult for consumers to accidentally call the dispose method, because it's just not there on the interface. That doesn't stop a caller then casting the instance that they've received through the interface back to the concrete type, but it's their foot, and if they want to shoot it, so be it. So we covered singletons. Let's go to the other end of the lifetime scale, where we've got transients. For these, not really a lot to say, other than be careful about doing a lot of work in the constructor, as you don't really have control over when these instances are created by the container. This could have major performance hit on your application if they're doing something like getting data from a database each time that they are created, rather than explicitly through a determined method call. Moving on, let's look at down the middle and go on to scope lifetimes. These need to be approached with caution and handled with care. In fact, I have seen various blog posts and tweets where people have said that they have banned their use on projects. I think that's a little bit drastic, but I totally understand the reticence even, as they can come back and bite you when you least expect it if used incorrectly. So hopefully, I'll try and clear up a few of the pain points. We've already covered how scoped instances should be used with other lifetimes. But what exactly is a scope lifetime? The commonly quoted answer is they're created by ASP.NET Core for HTTP request response lifetimes. But that's not the whole story. Whilst that is a common use case, a scope is not tied to ASP. You can create your own scopes. But that still doesn't answer what scope is. So in my mind, a scope is really there to ensure that objects are created only once within a single unit of work. So say you have several classes that all considered to be a single unit of work. You think a bit like a transaction in a database. Those classes interact with each other and all depend on receiving an iWidget instance in their constructor when created by the container. Therefore, you want to make sure that they all receive the same instance from the container. So in that respect, a scope lifetime is a bit like a singleton in that it allows the same instance to be shared between several consuming classes at the same time. However, outside that unit of work, the scope, you expect to get a different instance. So in that way, it's a bit like a transient. So to come back to the common use case of a web request, say Martin and I both make web requests. Those request response log pipelines are individual units of work, scopes, and therefore the scoped instances should be confined to each pipeline's boundary. However, as I talked about earlier, It is possible to accidentally promote a scope dependency lifetime up to a singleton if you inject it into a singleton's constructor. Away from the web, you might be writing a Xamarin or a console app, and you may want to manually create a scope yourself. This is done by calling the create scope method on the iService provider instance. This gives you back an iService scope with a single property of service provider, which is an instance of iService provider again. But this time you've created a boundary that serves up the scope services. Now that's all a bit convoluted and a bit of a mouthful to explain. So let's have a look at a high-level diagram. At the top, you have the root provider, which is where you usually get your singletons and transients. The create scope method on that then wraps a lot of what I've just talked about into creating a scope provider from which you get your scope services. In ASP.NET Core, the creation of scopes is taken care of for you when a request response lifetime is started. The server will create a load of service features, but the ones we're interested in is the request service feature. Now, as I described just now, the scope factory is used to create the scope as highlighted here. That scope is then used to create the scope service provider, which is then accessed from the HTTP context request services property. Now, that was all a bit sort of highfalutin. As someone who writes ASP controllers, all of this is hidden away from you. You kind of don't really care. All you need to really care about is that when specifying your dependencies in the constructor or action method of your controller or endpoint, that's what you're interested in. Is it scoped? Is it singleton? Is it transient? However, there is one area in ASP.NET Core where it is worth knowing what's going on under the hood, and that's middleware. Now, when we talk about middleware, we think about intercepting and handling HTTP requests and responses. Now, because of this, you might assume that the middleware is a scoped registration, but that's not strictly true, as there's two different ways of writing middleware. The one most people are familiar with is convention-based middleware, and now I've got that shown here. With this type of middleware, you accept a request delegate in the constructor and then call it from within the invoke async method to move to the next middleware in the pipeline. Either before or after that delegate call is where you do your own work. Now, in some cases, you might be writing terminating middleware, where you generate a response and don't really call the delegate unless you can't handle that response yourself. This is how something like static file middleware works, for example. If you have dependencies other than the HTTP context, you add these as parameters to the invoke async method, and they magically appear when the method is called by the pipeline. But how does that magic work? When you register middleware, it's done in the configure method of the startup class. Now, at this point, the container is already baked, like I said earlier, so you're not adding middleware to the container itself. Instead, what's going on under the bonnet is that what you're doing is inserting a delegate to the invoke async method. And what that will be doing is that does the actual work in the pipeline. So one calls to the next, to the next, to the next, to the next. To do that, you need to get a handle to that method and therefore go and create an instance. So underneath, a single instance of the middleware class is created by the use middleware method. When that single instance is created, any dependencies are resolved from the root container. Now, as we saw earlier, if the constructor is only called once, when you inject a transient or scope dependency into the singleton constructor, it will then become a captured dependency. What you do need to bear in mind is that the pipeline is created before the first request is received. So you won't be able to access anything related to HTTP context in the constructor, as it just doesn't exist at that point. This is while the pipeline is still being built. What will happen is you'll get an invalid operation exception thrown, as it can't be resolved at the time that the class is being instantiated to go and create the pipeline. Other scope dependencies that aren't part of the pipeline may resolve, but as I said earlier, they may become captured dependencies. So how does the request, which by nature is scoped, get dealt with? Well, the request moves through each layer of middleware in the pipeline, calling the invoke async method through the delegate chain. That's done through sort of kind of reflection and delegates, not through some interface or abstract contract. To do this, when the middleware is added to the pipeline, a request delegate is created. The delegate acts as a wrapper over the invoke async method, and as you can see, the request delegate is passed as a parameter into the middleware constructor to enable the request to be passed down to the next one in the pipeline. Now you're free to add any scoped or transient dependencies as parameters to the invoke async method if you need to use them in order to do some work either before or after the next middleware in the pipeline. Now in the previous example, I demonstrated how dependency injection works with convention-based middleware. Now the problem with the convention-based way of writing middleware is that it can feel a bit clunky and lays a few bear traps for you if you unwittingly declare transients or scope dependencies as constructor parameters. What is less well known is that there's an interface called iMiddleware that was introduced with ASP.NET Core 2. What iMiddleware interface allows you to do is to turn what we just described about convention-based middleware completely on its head. This time, the invoke async method has a fixed signature defined by the iMiddleware interface. Whilst we still get the HTTP context passed into it, now that request delegate is passed in via the method and not via the constructor. So given that the method has a fixed signature, we have to go back to the constructor to inject our other dependencies. What is different this time, though, is that instead of some hidden magic that uses reflection behind the scenes, the middleware instance is now constructed by the DI container. So unlike the convention-based middleware, this time we do need to remember to register our middleware with the container in configure services. Now, when we call the use middleware method to register the middleware, the method checks to see if our middleware type implements iMiddleware interface. If it doesn't, then it assumes that it's convention-based middleware. But if it does, it gets an implementation of the iMiddleware factory from the DI container, which in turn then calls the DI container to get instances of what we need in our constructor. Now that seems like an unnecessary extra hop to go via a factory, because the whole reason of a container is that it is kind of a factory. But the reason the factory is there is so that other containers such as AutoFact can register their own implementation. And if you go to the GitHub issues around the DI container, you'll see comments from the likes of David Fowler explaining why this decision was made. So those implementations from the other containers can use their own container to resolve the instances directly, rather than using the iService provider implementation itself. So going down this route, writing middleware becomes much more natural if you write it in the same way as you would any other class that you register with the DI container. If you're interested in finding out a bit more about conventional versus factory-based middleware and how they work with dependency injection, I do have a blog post that goes into more detailed comparison, describes how the two interact differently with the underlying use method on the application builder class, which is the thing that actually does the building of the pipeline for you. So earlier, I mentioned that you need to be careful with disposables, but now I want to dig bit deeper into some edge cases. If you remember, when I was talking about singletons, I said that you should hide the dispose method for consumers, as the container will take care of it for you. That last bit, the same is true in most cases, but as you can see here, there are a couple of extension methods where you create the instances yourself, and the container will not dispose of these for you. If you do create an instance of a disposable class in this way, there's a problem. Namely, there's no obvious re-entry point back into configure services method or to the startup class itself to get a reference to that instance to then go and dispose it. So why would you need to take that approach? The most likely reason is that you need to pass arguments to the constructor of that class, and those arguments just cannot be resolved by the container. If that is the case, you may want to consider using a factory. But if you really must do this, there is a get out of jail card. Behind the scenes, there's an interface that is automatically registered on the host called iHost application lifetime. This can be injected into the configure method by adding it to the method parameter list. Inside the method, you can then register a handler for the application shutdown event, which is past the object that you want to dispose of. Now that's fine if you just got one object that you've had to do that and it's a bit clunky, and it's really messy, it gets you out of a hole. If you've got lots of objects like that, Rather than setting up all this plumbing, my advice would be to wrap the object creation inside your own disposable class. You can then register that class as a regular singleton in the usual ways so that the container can dispose of it. And then inside the dispose method on your class, you can then go and dispose all those other objects. Now that approach doesn't just apply to that example. Coming back to hiding the dispose method, if you cannot change the disposable class as you don't own the source code, and it doesn't already have an abstraction that hides the dispose method, you may want to consider one of the Gang of Four patterns, such as facade, adapter, bridge, or proxy. These are all variations of the same kind of theme of basically writing a wrapper class to handle the creation and disposable of the class instance. The last point I want to make is a rare one, and it's a bit of a code smell. Sometimes you get a class that's outside your control that's known as a control freak. And what that does is it insists on disposing all the instances passed into it. Then instead of getting the container to create those instances, maybe you want to use a factory. So by using that factory, you serve something up that the control freak can dispose of, and you then don't get problems with your container. Next, we have some gotchas that can come up and bite you when registering or consuming services from the container. Consider what happens when the same service type gets registered multiple times against multiple implementations. Now, you may well be doing this deliberately because you want to have several implementations that you want to iterate through. These might be maybe a set of validation rules or a collection of processing things that form some kind of enrichment pipeline that you use with the visitor pattern. However, more than likely, it's probably happened by accident. So, for example, you may have a source code merge that's gone wrong and the same line's been duplicated. Or there may be extension methods registering a different implementation to the one you're registering and you don't know about it. Whatever the reason, there can be unintended consequences because the way the container works is namely the last in wins principle. So if you call an extension method after your registration, it'll be the extension method's implementation that'll be the one that gets resolved by the container. So you need to give some thought as to the order in which you set up the dependencies in configure services. Now, of course, if you're writing an extension method, especially if you're publishing it to a wider audience via NuGet, the onus is on you to play nicely. As we know, there needs to be care around lifetimes and things get messy if there's multiple registrations with different lifetimes. So you may think you've registered a singleton, but something else comes along and trumps it with a transient or scope registration. Now, it may be that, as I mentioned just now, you deliberately want multiple implementations. But if we want to avoid accidentally registering the same service multiple times, there's two ways out the box to do this. The first is to use the try-add methods, where the first registration is kept and subsequent registrations are ignored. So we flip the last in wins principle over to first in wins principle. The second approach is to use the try-add enumerable methods, where both the service type and the implementation type are taken into account. So in the examples shown here, the try-add singletons will result in just one registration, even though it's been called 6 times. Try-add enumerables will result in 3 registrations, as the implementation type is also taken into account. So that's the gotchas. Now let's look at some helpful hints and tricks. Flipping what I've just talked about on its head, you may well be deliberately registering multiple implementations that callers do need to iterate over. I gave a couple of examples just now about validation rules or enrichment pipelines. If you plan to do this, the consuming class needs to know that there will be multiple registrations. This is done by explicitly requesting an IEnumerable of the service type to get all those implementations. If you don't do this, the instance you'll receive will either be the last in wins, or the first, if you use the triads, you just get one instance and you don't really know that there's other ones there. If the order of the enumerable is important, there needs to be a way of differentiating each instance. Without that, the consumer will have to rely on the order that the registrations were performed. Now, there's lots of ways of handling that. One is to create a comparer that implements the iComparable interface for your service type. That can then be used with an order by in the link statement inside your consumer once you've consumed the IEnumerable. You could create a dedicated class that implements IEnumerable interface, and the caller requests that. But for that to work, you would need to inject the IEnumerable of the service type into it, and then have some ordering logic inside, so it's a bit more complex. Lastly, if it's just a handful of things, you may decide to register a Lambda expression directly inside the container. And when the consumer calls IEnumerable, that gets served up and it applies your order logic for you. Going the other way around, you may have a single class that has multiple interfaces, especially if you've gone down the interface segregation principle route from Solid. If you register the type for each interface individually, each registration will create a distinct instance, when really you probably want the same instance returned, especially if it's a singleton or scoped. If you want to access the same instance through the different interfaces, you should register the instance first by its class type, then use a Lambda expression using the getRequiredService method to resolve the main instance from the container and return it via the interface. Now, in some cases, you may want to aggregate the interfaces together into a composite interface as shown here. This can be a benefit if you don't want consumers to be able to request the concrete implementation directly. If you think back to what we were saying about the disposable issue, where you want to hide the dispose method. So rather than registering the concrete, you register it with the composite interface, so you've hidden the dispose method. Next, we have open generics, where you define a type parameter on the class type. Now, the place you may be familiar with this from a DI perspective at least is the generic iLogger T interface, where you may be using it in your controller constructors to get an iLogger instance that is specified by your type of controller. Similarly, you may be familiar with the iOptions interfaces that get registered when you use the configure method to bind configuration to objects even. If you want to register your own generic type, the C# syntax doesn't lend itself to referencing open generics within a generic declaration. So instead, we have to use the non-generic registration methods where we use the type of keyword to get the service and implementation types without giving a closing type parameter. In the case shown here, the I do something generic interface and do something generic class are shown with the angle brackets, but without the closing type parameter, as these will be supplied by the consumer. Behind the scenes, the container makes use of the make generic type method on the type class to go and create the closed generic type. For example, do something generic of strings, bad example, but you get where I'm coming from. It then uses that type with a bit of reflection magic to create a closed generic instance to return to the caller, but do something generic of strings. If you haven't moved to .NET 5 yet, you may well hit a problem though if you've applied a generic constraint to your type, such as limiting it to be in a class or maybe implementing a particular interface. The problem is that the make generic type inside all this reflection magic was throwing an argument exception prior to .NET 5. Luckily, that's where Jimmy Bogard of Automapper and Mediator fame has come to the rescue. He did a pull request that added a try-catch block around the make generic type and swallowed the argument exception. This now allows constrained generics to be resolved in .NET 5. That's great, except it took 4 years for his pull request to be accepted. Now, if you read Jimmy's blog, you get to understand why there's been very little change in the Microsoft container since the first version of .NET Core. Excuse me. In short, to get a change accepted into the main container repository, you have to make sure that all other container technologies that implement the iService provider interface don't break, which in turn meaning having to write loads and loads of unit tests that make sure that what you'll bring into the change not only fixes something or brings something new to the party, but that it doesn't break all those other containers as well. Next, I want to talk about a couple of so-called Gang of Four design patterns that are relevant to the DI container world. The first is the factory pattern, which I've mentioned in passing throughout this whole talk. Now, you may be thinking, Steve, surely the whole point of a container is to be a factory. So why do I need to write a factory class? Well, sometimes you have to give the container a bit of a helping hand. For example, you may have a class where some of the constructor parameters aren't known until runtime, as they may be captured from, say, user input. In those cases, you can't get the container to create the instance for you because the container's got no idea about those user-entered parameters. That's not unless you do something really hacky involving async local. We're not even going down that road. It may be that the instance to be created needs to be disposed of quickly, as it's a resource hog. So you want to be able to dispose of the instance as soon as the caller has finished with the resource. Rather than wait for the container to dispose of it, you want the caller to call dispose on it. So lastly, at the start of the talk, I mentioned that the Microsoft container doesn't support property injection. But by using a factory, we can effectively simulate property injection by getting the container to instantiate the class and then set property values before returning the fully prepared instance. So these are just a few cases where the factory pattern comes into its own. So, as a very quick and very contrived example, we have a class here that will register as a singleton. Next, we're going to create a class that consumes that singleton, but also requires a name parameter in the constructor. Now, given that the name parameter can't be known by the container, as it's going to be provided by runtime by our API controller, we can't add it to configure services. Now, you may notice I've used an immutable class here, but with C#9, I could have used a record type. Now we will go and create a factory class. First, we'll take the singleton and cache it in a field, as shown in the blue highlighted constructor here. We then have a creation method that will go and new up our short-lived thing class using a cache singleton, and then a value passed into the name parameter that we've got on our factory method. Next, we add the factory to the configure services as a singleton. And finally, we have our controller that takes our factory in the constructor. Later in the get action, it then calls the make method to create a new instance of the short-lived thing. Now that's very contrived, I know, but I wanted to give some flavor of using the factory. And sorry about the small font on this slide, but as you see, I had to pack quite a lot into that slide. So to summarize factories, usually you register the factory as a singleton, as most of the time it's stateless. The variations are the parameters in the create method. As it's a singleton, the only other dependencies that should be injected into it are other singletons. If you need transients or scope dependencies, you can take the iService provider itself as a constructor parameter, but proceed with caution. Direct use of the iService provider is considered a version of the service locator anti-pattern. The reason is that it's an anti-pattern is that it's kind of tight coupling your classes to container interfaces, which in most cases you don't really want to do. You want your classes to be oblivious to the container technology. However, the factory pattern classes fall into a group that I personally refer to as servicing classes. These are plugging the gaps in the container functionality that are effectively an extension to the container. So with that in mind, I think that as long as your factory classes are seen in that context, and you don't go referencing iService provider wholesale throughout your application, I'm fairly relaxed about doing this, as it's more about being pragmatic rather than dogmatic. If you're worried about the factory classes exposing the anti-pattern and the coupling, you could always go and create an abstraction through an interface and then hide the class inside your startup class, so you only expose the methods via the interface as a service. Variation of the factory pattern is the builder pattern, where rather than prescribing each dependency that are needed up front and then creating the instance immediately, the builder is much more flexible. The way I compare the two patterns is to think of the two as ways of ordering drinks in fast food restaurants. The factory is like asking the person to serve you a cola. They use a standardized dispenser, as we've got on the left here, with a fixed set of options to make a standard drink. With the builder pattern, it's much more nuanced, and it's more like the modern dispensers you see here on the right, where you can say, I want a cola, but I want a dash of lime flavoring, possibly a dash of vanilla, and then some cherry. gradually composing it up bit by bit until you have the finished drink that you want. But with the builder, we start off very much like a factory by registering it with the container. However, this time we register it as a transient, as you're going to be mutating the state of the builder once it's been created. In its constructor, we can take in other dependencies from the container. Consuming classes then take the builder as a constructor parameter and then start using the methods and properties to build up the instance to be constructed. Once we've got our configured builder with everything that we want, we've set all our properties, we can then call the build method to go and create our instance. Now, typically, that resulting instance will be immutable because you've done all your work in building it up. The last thing I want to mention is that, like a factory, if the instance you create out of the builder is an disposable, this time it's the caller's responsibility who did build to then go and dispose that instance, because the container has taken no part in the creation of that object, so it doesn't know about it and therefore it won't go and dispose it. Now, so far, we've assumed that the factory or builder classes will be using the new keyword to instantiate the class instances. But wouldn't it be good if we could take advantage of the container to create the instance for you? Now, in the earlier slides, I said the problem was that the container has no knowledge of some of the parameters because they've been supplied at runtime. So how can we deal with this? Luckily, that's where the activator utilities class comes in handy. There's 4 methods. There are effectively 2 methods with generic overloads. The get service or create service will try and get the container to create an instance for you, but if the type isn't registered, it'll do it using reflection. The other method, and the one that's of interest to us as writers of factories or builder classes, is the create instance method. What this does is takes an instance of iService provider to get an inroad into the container, and then it takes an array of objects. It then does the heavy lifting work of taking those various objects and trying to match them up to the order that the constructor requires them on the object. Now, the downside to this is that because it's having to do that mix and match, there's a slight performance hit. But if you've got lots of these things, you may want to do that rather than to write lots of boilerplate code of doing the new up yourself. So we've got, what's the time? 10 minutes or so. So in this final section, I want to talk about plugging in some of the gaps in functionality that the Microsoft container is missing. I mentioned earlier that the property injection isn't supported out of the box by the Microsoft container. But you can get around this by using a factory or builder to go and create the instance and set the properties before returning the instance that you've done your properties on through the create or build method. Another place where this can be useful is if you need to create instances of a struct value type, where some of the properties need to come from a container. The problem here is that you simply cannot register value types with the Microsoft DI container, as it's just not supported. So you need to get all the dependencies and instantiate the value type yourself. Here you can see I'm attempting to add the struct type registration using a generic add transient. And here's the Rosin analyzer error to tell you that, sorry, no can do. So you could think, aha, it's because I'm using the generic registration. I'll try the non-generic version. That's great. You don't get a compile error, but all you've done is you've kicked the problem down the road to become a runtime error. So how do we get around this? We simply create a factory or builder that takes the parameters needed to populate the value type. Now, the example here is contrived and doesn't really offer any benefit of just creating the object in your own code. However, if some of the properties need to be taken from the container, this is where the factory can grab these from the constructor or via the service provider and then put them in via the method parameters. Which kind of leads us to the new C#9 record types. Now, I'm a big fan of these and that make heavy use of them in a project I'm working on at the moment. For those not familiar with these, they're reference types like classes, but they behave like value types when it comes to things like equality checking. They also offer a simplified syntax for creating immutable objects. Now, if you want to find out more about them, I like the on.net show video that there's a link to here. From a DI perspective, as they're reference types, you can register them with the container. However, given that record types are mainly for use as entities, you're more likely to use the factory pattern for the same reasons I've given in the previous slides about value types. If you are interested in finding out more, I do have a blog post that shows how to write a record factory, and it also covers a lot of what I've just talked about with factories overall. Next, we have something that no one really talks about with dependency injection in C#. We nearly always talk about classes and interfaces being registered with a container, but delegates are also a first-class citizen, can also be registered. Now, in theory, we could register the anonymous delegates from the funct family, but these are hard to distinguish from each other because they all sort of share a common generic signature. So instead, we go old school, back to something that doesn't get much attention these days, and that's custom delegates. Now, I go into details on my blog, but I'll give you a quick example. Now, I really hate system date time now property. It's non-deterministic. By its very nature of being real time, it's hard to test. I don't really like using it in my code. So what can I do to get around that? What we can do is go and create a delegate function that will call the system date time now property on our behalf. The signature of our delegate in this case is a function with no input parameters, but it does have a return type of date time. By creating the delegate, we're creating an abstraction without all the ceremony of have to first go and write an interface, then go and write an implementing class and go and register the class against the interface. This takes all this out. It also feeds into the single responsibility principle as the delegate does just one thing. If you want multiple date time related functions, you may still want to write an interface in a class. But if those functions don't share any logic, you could just go and create multiple delegates. Now, this is where the custom delegates have the advantage over the funct family, as the delegates can all have the same signature, but they're distinguished by the delegate name. And under the bonnet, each one is effectively a class. If you do try and use the funct family, they may all have the same function signature, and therefore you do fall into the multiple registrations trap that I described earlier. From a unit testing point of view, though, the delegates are very easy to mock or go and create your own implementations, as at the end of the day, they're just functions. So you could have your own mock function that returns a very specific static date time that you can use in your assert statements to compare within your unit tests. Now, you may notice I've registered the delegate as a singleton, maybe thinking, well, hang on, surely that date time that gets returned is going to be captured the first time it's called. That's not the case. As we've seen with the middleware pipeline, what we're doing is we're capturing the pointer to the function, not the actual function results. So in this very contrived example, I consume the delegate in the controller constructor and I cache it in a field. I then invoke it at the time of the constructor is run and go and cache the result in a field. In the get action, I then force a 3-second delay, and I then call the delegate again. This time, I create a return string with both values. Now, as you can see here, the result shows that even though the delegate is a singleton, the result is not generated until invoked. The first invocation is in the constructor, and the second is in the method, and hence the 3-second difference in the shown result. A feature that is supported by other containers, such as AutoFag, is being able to specify a dependency to be resolved by the container using a string name or a key. It's considered a bit of an anti-pattern as it comes back to the idea that your application code shouldn't really know about the container's mechanics. But what if you could do it without your class having to know about the container? So this occurred to me a while ago when I had a situation where I had type mappings algorithms determined by a runtime value that was coming out of a database. So rather than write a massive hard-coded switch statement inside my repository class that would need to be updated each time a new value came along when the database is updated, I wanted something that could be injected from the container to just give me the mapping functionality that I needed. Now, that's a bit of a long-winded way to describe here. So the link to my blog post gives you a bit of an idea of what's involved, but I do have a very contrived example where what we do is we create a common interface and some classes. So here we have a temperature converter that takes different scales to Kelvin. So we've got centigrade, Fahrenheit, Rankine, and Kelvin to Kelvin, a one-to-one mapping. We then register them all with the container as their actual types. Now, following on from what I was saying about using delegates, we also have a delegate declared here that takes a string and returns an required implementation of the iKelvin mapper. Now, in the code here, I've used a simple switch statement based on character value, but I could have done something more advanced using dictionaries or possibly custom attributes on the implementing types, or maybe pattern matching. Whichever way you choose to do it, the delegate is the secret sauce, as it allows us to lift the logic out of the consumer and up into the container. The consumer will use the delegate to pass the string value and get back the correct mapper instance that it needs. In other words, we have something along the lines of an abstract factory pattern. So now we have a consumer class called getTemperature, and that has a method to take a scale as a string and a decimal value that is the value that we want converted to kelvins. Now, our class at this point has no knowledge of the container's iService provider, and it doesn't have any idea about the implementation of how we get that converter. All it knows is that we call the delegate, pass it a string, we'll get back the appropriate converter that we need to convert that scale into kelvins. So that was a somewhat contrived and simplified example of using inline switch statements. If you're interested in looking into using lookup dictionaries or anything more advanced, Frank Quednow has written a blog post that takes my example further and points out some gotchas around using the dictionaries and iService provider, because there's things around closures that you need to be aware of. The Decorator is another gang of four pattern that can be used to extend the functionality of the class by wrapping it and then re-implementing all the members, but where necessary, intercepting the incoming parameters and outgoing results to something new. A common example is to add a logger so that every call to the method's input and output gets logged. To do this, though, we still need the original class to be injected into the decorating class along with other dependencies, which in our case is a logger. In the example code here, we have a class called doSomething that implements the iDoSomething interface. First, we register the class as a concrete type and not through its interface. We then have a decorating class called logging_doSomething that takes the registered original class and also requests an instance of iLogger. It then re-implements the getHello message method, this time with code that intercepts the input and output of doSomething's version and writes these out to a log. We then go back and register the new logging_doSomething against the iDoSomething interface, which is then used by the consumers. So the last missing feature from the Microsoft container that is supported by others is registration of services by convention and assembly scanning. Still a long mouthful, like I said at the beginning. Now, I'm not personally a big fan of doing this, as I'm a bit of a control freak, and I like to know exactly what's going on with all my registrations. As we saw earlier, it is possible for registrations to stamp all over each other, and depending on the order that they're registered. And that's why I don't really like being out of control and handing over that control to some other automated process. However, if you have masses of classes to register, this can be a laborious task, having to type in add singleton, add scoped, etc., etc. So I can understand why you might be looking for a shortcut. Now, several offerings out there, but probably the most well-known is Scrutor, where you can define rules of criteria for registering classes and interfaces. One nice thing I do like in Scrutor is also the ability to register decorating classes with a much simpler syntax than the hand crank version that I showed just now. So, We've packed an awful lot into this last hour. I hope it's been helpful. I've had to go at quite a fast pace. If you've been watching on YouTube at 1.5 speed, good luck to you. We've gone beyond the basics of dependency injection in .NET Core and .NET 5. I think for me, the highlights from this talk are things like understanding the different types of injection when you may want to integrate with other containers, how the service lifetimes work with each other and avoiding captured dependencies. We've looked at different ways of writing middleware and how it determines how they work with the container. In the gotchas section, we talked about deliberate multiple registrations and how to avoid accidentally registering services multiple times. We've talked about design patterns such as factory builder and things like facades where you're having to wrap things up to hide some of the functionality. We've covered then how you integrate those with the container. Similarly, we've now looked at things like custom delegates, which can be used to provide missing functionality without having to resort to using other containers. That just about wraps it up from me. If you want to hear any more of my ramblings, I'm on Twitter quite a bit. I do have a blog where I've written mainly about dependency injection and configuration, though I've started looking at things like source generators just lately. Back in November, I recorded an episode of the .NET Core show with Jamie Taylor, which I believe should be coming out in the next few weeks, but I'm not 100% sure of that. Next, a few honourable mentions. The Microsoft Docs page, well worth a look at. That's sort of a great place to go and find out information, especially if you're migrating from things like Core 2 to Core 3 or to .NET 5. Andrew Log has a brilliant blog that covers all sorts of .NET Core and ASP.NET Core things. And the second edition of his book, ASP.NET Core in Action, has just been published this week. Purely by coincidence, when I checked Twitter this morning, Manning, who it's published by, have a half-price sale of the book today. So if you're watching this live, you've got until midnight US Eastern Standard Time. You can go to manning.com/DOTD to go and get the deal of the day page. You can get the ASP.NET Core in Action second edition, plus a couple of other .NET Core books. Last but no means least, Mark Seaman's blog and his dependency injection book are well worth getting a look at to get a bigger picture of DI patterns, anti-patterns. It also covers all the non-Microsoft containers and how they all compare each other. And then there's a chapter towards the end about the Microsoft container. And with that said, my hour is up. Thank you for coming along to watch my talk. I hope it's been of use to you. Martin, if there's anything in chat, I will try. I can't promise I've got an answer, but I will try and answer some questions.
Absolutely. First of all, I really want to thank you for this talk. I found it amazing. I also felt it was a little bit 5 talks for the price of 1. So
sorry, I did go at a rate of knots through that.
I've seen people give some feedback on that as well. So lots of people saying, great talk, Steve. Thank you for the insights. I didn't know about delegate injection. That's cool. Can I get an autograph? Is one that just came in.
A virtual one.
Yeah. So yeah, I guess job well done.
Thank you.
There are a couple of questions.
Sure.
And I'll bring them up. By the way, if anyone watching has more questions, feel free to put them in the chat and we'll try to answer them as well. Let's start with the first one from Max T, who asked, Steve, could you talk a little bit about how all of this fits in with API level unit testing? For example, where you would start with a host factory in your tests and then test against HTTP or gRPC and change some registrations based on the test you're writing.
Okay, so bit outside the scope of this talk, but what I try and do is I try and refactor my startup class into such a way that I can use the a factory around that, so that I get my I get my iService collection out of my startup class, but before it gets called the build service provider, I then go and overwrite some of those dependencies with my own dependencies. Now, I think on the iService collection, I think I'm right in saying that there's a remove method where you can take out something that's already registered and go and replace it with your own. some circumstances you could get away with just registering your own after the event, but comes back to the last in wins principle. So that even though unless you've got something that's requesting an IEnumerable of some dependencies, if it's just got a single dependency, say iWidget, you may have registered iWidget as a certain concrete type within your startup class. But then if in your unit test, if you then take that iService collection, register your own unit test iWidget, and then call build service provider, that your widget will overwrite the widget that was previously there. I could probably do a whole talk on that subject alone in its own right.
Yeah, I was actually thinking, because I had a question of my own about create scope, but I was thinking maybe in unit tests you could create your own scope and just register whatever you have based on the test in principle, and then get started with it.
I think it gets a bit tricky with sort of if you've got APIs, because you sort of try and take over what the ASP.NET is trying to, and it could get a bit tricky. But if you just wanted to test stuff about scopes, and that's where inside your unit test, you could use that validate scopes method on the host builder, and also the validate on build, validate after build. I can't remember the exact name of it now, but you could use those things to go and write unit tests around, and also they're limited to the development method, so that you could scope those whilst you're just in a debug mode effectively.
That's another good approach, I think. One question that I actually had was around create scope. I've used it before in some cases, but did you have any places where you would actually start using create scope and create your own scope for certain things in your application?
In ASP.NET world, probably not, because you've kind of got your scope already about your whole request response pipeline. That's kind of taken care of you. Certainly, you may want to do it in a console app or a Zarin app, where you want to sort of, comes back to this idea of the unit of work. So something where you've got a unit of work, or something, I tend to align it with thinking about things like database transactions, where I just want to say, I've got this whole thing and I'm dependent on this thing inside. So I might have 5 different classes or interfaces that are dependent on something. And I want that to be the same, but I want it to be different on different transactions effectively. Scope is one of those things that's really hard to try and describe. The other thing to watch out with create scope is that it's disposable, and you need to make sure you dispose your scope if you're doing it manually.
All right, thank you very much. I see one more remark coming in about the Manning website and Andrew Logg's book. So thank you for giving the link. And
that's right. It's pure coincidence that came through on my Twitter feed this morning. So that was well timed.
And with that, I think we can probably start wrapping up. If you like this video, give us a thumbs up and subscribe to our channel if you want more webinars later on. More information about us is on our website, of course. You can follow us on Twitter, and you can also follow Steve on Twitter. If you have any questions after watching this, probably at 0.6 speed afterwards, you can ping Steve on Twitter and get in touch, or get in touch with us as well. With that, again, thank you for joining, and find more screencasts on our JetBrains TV channel here on YouTube.